In this lesson, we're going to introduce the idea of solving rational equations. And these are all going to have kind of a specific look to them. They get more complicated, but we won't deal with that in this video. That'll be for another video. So let me show you what we mean by that. So we're going to have a rational equation, which means we're going to have a variable in the denominator, and it's going to be set equal to something. Okay? And like I said, on these, they're all going to have kind of a similar look, a similar feel to them. And basically what we have is we're going to have a fraction equal to a fraction. Okay, we don't quite have that. Doesn't mean we can't. We can make it a fraction just by putting that over 1. And now we have a fraction, which also means we really have a proportion. So a fraction equaling a fraction is really a proportion, and we can always solve a proportion by cross multiplying. Okay, so we're going to cross multiply, and this is going to be one cross product, this is going to be another cross product, and we're going to go about solving that. So first cross product is going to be 2 times x, and then the second cross product is going to be 3 times the x minus 1. So one cross product is 2 times 1, which is 2x. And when you do have a proportion, the cross products equal each other. That's actually what can get us out of the fraction. So there's the other cross product. It's 3 times x minus 1. So we're going to distribute that in. So that'll get distributed in. And that'll get us a 2x is equal to 3x minus 3, and we're going to try to move the x's over to one side, so subtract 3x, that'll get us a negative x equals a negative 3. We'll divide both sides by negative 1 to get the x by itself, and x is going to equal 3. And the very first time we'll kind of plug it in to make sure that show you that it works. So if you take the 3 and you plug it in, we're going to have 2 times 3, and then 3 minus 1 is supposed to be equal to 3. 2 times 3 gets us 6. 3 minus 1 is 2, and 6 divided by 2 is 3, so it checks. So one thing that we have to discuss, though, that's different from other equations because we have a rational is we have a domain issue to this. We have a number that we cannot get as an answer, and 3 was our answer and it checked. However, at the very, very beginning, we should have talked about what we can't get. And we can't get a negative or a positive 1. If we got a positive 1, it would make our denominator 0, and we can't divide by 0. So even if this math seems to work fantastic, we cross multiply, we solve, and we get a 1, it'll cause us a problem when we go back and check it. So right at the very beginning, first thing we're going to do on the next couple problems is we're going to figure out what number causes us to have a problem. And if you don't see it, really what we're doing is we're taking the denominator and setting it equal to 0 and solving. So 1 minus 1 would make the denominator 0. We got a 3, so we're okay. Okay, so let's do another one. So if we have 3 over x minus 2 equal to 2 over x minus 3. Alright, before I do anything, the very first thing is determine what my x cannot equal. These are my constraints. X can't equal 2. And x can't equal 3. So 2 would make that denominator 0, 3 would make that denominator 0. I just got to keep that in the back of my mind. So now we'll cross multiply. So this cross product is going to be 3 times x minus 3. And then that's going to equal this cross product, which is 2 times x minus 2. So we'll distribute. That'll be a 3x minus 3, or minus 9. Distribute, that'll be a 2x minus 4. So I want to rearrange. So I'm going to move the x's over to the left. I'm going to move anything without an x over to the right, or constants. So I'm going to subtract 2x, and I'm going to add 9 at the same time. So those go away, and that'll leave us with x equal to 5, which is not one of our constraints, so there's potential that that answer works. I would plug it in to make sure that it actually does work. All right, let's do another. So if we have 4 over x minus 3 equal to x. So very first thing again, do we have a fraction equals a fraction? If we do, we have a proportion, which means we can cross multiply. We almost do. Again, we can make it a fraction by putting it over 1. And now we can cross multiply. We have a proportion. So this is one cross product, so that's 4. There's our other cross product. That is x times x minus 3. And we'll distribute. So that'll get us an x squared minus 3x is equal to our 4. Now we have a different kind of equation. We have a quadratic, and so we need to get everything over to one side. So we're going to bump the 4 over, which will leave us with a 0, and x squared minus 3x, and then we'll have a minus 4 because we'll brought the 4 over, and we'll look to factor it. And since there's no number in front, what multiplies to negative 4 that adds to negative 3? And that would be a negative 4 and a positive 1. And then we can set each factor equal to 0 because we have the zero product property happening. Alright, so on this one, x is going to equal 4, x is going to equal negative 1. And I should have done this at the very beginning, but based on my denominator, 3 would make the denominator 0. So I can't have a 3, and we got a 4 and a negative 1, so we're good. So this one actually has two answers. So if you plug a 4 in, you'd actually get a 4. If you plug a negative 1 into this, you'd get a negative 1. And those would check out. Alright, we have one more. Okay. So the last one is x over x plus 1 equals 2x plus 1 over x plus 1. So we have a fraction equals a fraction, so we can cross multiply. We have a proportion, so one cross product is going to be x times x plus 1 equals x plus 1 times this cross product, 2x plus 1, and we will distribute everything through and start to rearrange. So this is x squared plus x. This would be x times 2x is 2x squared. X times 1 is x. 1 times 2x is 2x. 1 times 1 is 1. Alright, so it's looking like we're going to have a quadratic, so we're going to need to bring everything over to one side. So I'm going to subtract the x squared, subtract the x, line them up under their like terms. Alright, so that goes away, so you have a 0 equals x squared. Those cancel each other, so we just have a 2x plus 1. And 0 equals, is this factorable? So this factors into what multiplies to 1 that adds to 2, a 1 and a 1. So x plus 1 equals 0, x plus 1 equals 0. We would move the 1 over, so x equals negative 1 and x equals negative 1. So what answer could we not get? So what would have made the denominator 0 in both of them? Actually, x could not equal negative 1 on either of them, we got an answer of -1. So those don't work. So if we plug those back in, we would have a number divided by a 0. That is undefined, so nothing works. So that is a no solution. All right. Now there is a little bit of a shortcut to this that can happen. And again, it's really a recognition. If we have the denominators matching, the shortcut is that the only way, if the denominators match, the only way that these fractions are going to equal each other, because no matter what you plug in for x, the denominators are already going to match. But we got to figure out when the numerators match as well. So if the denominators already match, so if denominator so if they match, you can skip the cross multiplying part and you can just set numerators equal to each other. So watch how this works. So in the back of our mind, we still have this fact that x cannot equal -1. Okay, that doesn't go away. But denominators match, so we're really just trying to figure out when the numerators match as well. So x just equals 2x plus 1, and we start to solve. So we'll subtract the 2x over, and that will give us a -x equals 1, and divide by -1 on both sides, and that gets us x equal to -1. However, we get the exact same answer. This one just gave us 2 of the exact same answer. This one gives us 1, but it's still a problem. It's not going to change. If it was a problem in this method, it's still going to be a problem in this method. So that also is still a no solution. But if you recognize that the denominators match already, set the numerators equal to 0, you're going to have a smaller equation and a more simpler equation to deal with. So that was the beginning of solving rational equations.